In this question, we have a uniform disk which is moving rightward with velocity 20 meter per second and angular velocity 4 radian per second in this fashion. It is moving towards right, and it is saying in question that this is the initial state and it moves towards right and suddenly it gets hinged at point A. So, whenever it hinged at point A, its angular effect will be instantly 0, but due to this velocity towards right, it will start rotating in this fashion. So, this will be new angular velocity omega and in anti-clockwise direction. Disk has mass as 1 kg and its radius is given as 1 meter. To solve this question, we can apply conservation of angular momentum. So, from conservation of angular momentum, we can apply conservation of angular momentum about this line. So, initial angular momentum of this disk will be m v naught r minus I c omega naught. Why? Because this omega is rotating in clockwise direction. So, its direction is towards into the board. So, we suppose it as negative. So, it will be minus of I c omega naught. And the final angular momentum of this disk after hinged at point A will be I a omega. I is what? It is a moment of inertia about this point A. By solving this relation, m v naught multiplied with r minus I c, this disk moment of inertia about point C will be m r square upon 2, and moment of inertia of this disk after hinge at point A about point A will be m r square plus m r square upon 2 multiplied with omega. You see, we have m r in each point, so it will be gets cancelled. So, we will have 2 v naught minus omega naught r multiplied with divided by 2, which will be equal to r plus r by 2 multiplied with omega. This is what 2 v naught minus omega naught r upon 2 equals 3 r upon 2 omega. This 2 will gets cancelled. Therefore, omega will be 1 by 3, take it out, 2 v naught upon r minus omega naught. By putting these values, these data, v naught 20 meter per second, omega naught 4 radian per second and r 1 meter, in this relation we can get omega. So, it will be 2 multiplied with 20 divided upon 1 minus omega naught is 4. So, by solving we will get 36 upon 3, that is what 12 radian per second. So, our omega final angular velocity of the disk will be 12 radian per second, and this is the desired result for this question.